What we are going to do in this video is to study a proof of the Pythagoras theorem that was first discovered, or as far as we know, first discovered by James Garfield in 1876. And what is exciting about this is he was not a professional mathematician. You might know James Garfield as the 20th President of the United States. So, what he did, he constructed a right triangle with A, B, and C as sides of that right triangle. He then flipped and rotated this right triangle to construct another one that is congruent to the first one. So these two right triangles are congruent. Let us say if this angle is theta, and this is 90 degree, and we know that the interior angle of any triangle is equal to 180 degrees. So if this is 90 degree, this angle and this angle must be equal to 90 degree. So if this is theta, this angle will be 90 minus theta. Now that these two right triangles are congruent, so the corresponding angles will be same. So if this is theta, the corresponding angle is this angle. So this angle will also be equal to theta. If this is 90 minus theta, this angle must be equal to 90 minus theta. So if this is theta, this is 90 minus theta. What about this angle? What is this? So let's find this angle. This is theta, this is unknown angle, and this is 90 minus theta. This whole is equal to 180. This angle, and this angle is equal to 180 because we have a straight line. This is a straight line. So let's write theta plus 90 minus theta plus this unknown angle is equal to 180. So now we can solve this equation for the unknown angle. We have plus theta and minus theta. So plus theta will cancel minus theta, and we will get this unknown angle as 180 minus 90 is equal to 80. If we add minus 90 here and minus 90 here, so the unknown angle is equal to 90. So this angle is also 90 degree. So we have three right triangles. We have three right triangles, 1, 2, 3. And if we look, we have constructed a Trapezoid. Yes, we have constructed a trapezoid. This is a trapezoid. This is a trapezoid, and within this trapezoid, we have three right triangles, one, two, and three. So the area of this trapezoid must be equal to the area of this right triangle, the area of this right triangle, and the area of this right triangle. So we can write area of trapezoid is equal to area of three right triangles. So, so let's find the area of trapezoid. We know that the area of trapezoid is height of the trapezoid. What is the height of the trapezoid? Height of the trapezoid is a plus b. So height of the trapezoid times average of top and bottom, average of top and bottom. So let's write it. Height, this is the height of the trapezoid, multiply average of top and bottom. Top is a, bottom is b, so average is half a plus b. Now let's come to these three right triangles. These two triangles, the area of this triangle and this triangle, they are, the area is same. So what is the area of this one triangle? The area of this triangle is half a into half a into b. Since we have two triangles, so we can write 2, this for two triangles, into the area of one triangle. The area of one triangle is half a into b. Now come to this triangle. The area of this triangle is half c into c. So let's write it plus half c into c. Now we can solve this equation easily. Uh, we have a plus b into half a plus b. So this a plus b and this a plus b will make a plus b whole squared. So we can write half a plus b whole squared. Now this 2 will cancel with this 2. This 2 will cancel with this 2, and we will be left with a into b. So a into b, and then half c into c means c squared. Now we have half here, half here. So let's remove this half by multiplying all the three terms by 2. Let's multiply all the three terms. We have three terms. This term, and this term. Let's multiply all these three terms by 2. So if we multiply by 2, this term will become a plus b whole square, and this will become 2ab. This will become 2ab, and this will become c squared. Now we can expand this expression. It is a squared plus 2ab plus b squared is equal to 2ab plus c squared. We can write 2 into a into b as 2ab. Now we have 2ab here and 2ab here. So if we subtract 2ab from this side and 2ab from this side, we will be left with a squared plus b squared is equal to c squared, and this is our Pythagoras theorem. Hence, the Pythagoras theorem has been proved